All right, guys, we have another system of equations problem right here. Again, 3 equations with 3 unknowns. All right, let's get to it. We know what we've got to do. We've got to take out 2 of these equations and cancel one of the variables. So what I'm going to do is I'm going to choose equation number 1 and equation number 3. I notice that I have a 2x here and a minus 2x here. And so if I were to add, if I were to take equation number 1 and add equation number 3, then my x's will cancel. So let's do that. I have 2x minus 2y plus 3z is equal to 6. And that's equation number 1. Equation number 3 is minus 2x plus 3y minus 7z is equal to 1. And if I now add these 2 together, add, not subtract, then my x's will cancel. 2x plus minus 2x is 0x. Negative 2y plus 3y is plus y. Negative 2 plus 3 is plus 1. And 3z minus 7z is minus 4z is equal to 6 plus 1, that's 7. All right, so I now have one equation in 2 unknowns. All right, so I've made some progress. All right, let's take another 2 of these equations. Let's try taking equation number 3, multiplying it by 2. That will give me negative 4x. And then if I add it to equation number 2, then my x's will cancel again. And of course, remember that I want to make sure that I'm canceling the same variable both times. Here I canceled my x, so I also want to cancel my x next time. So what I'm going to do is I'm going to take 2 times equation number 3, 2 times this equation, and I'm going to add equation number 2. All right, let's put it up here. So that will give me negative 4x, negative 4x, it's 2 times equation number 3, plus 6y minus 14z is equal to 2 times 1 is 2. All right, so this here is now equation number 3 multiplied by 2, and to that I'm going to add equation number 2, which is 4x minus 3y plus 2z is equal to 0. I add these together, my x's will cancel, of course, that's what I intended. 6y plus negative 3y, so that's 6y minus 3y is 3y, 6 minus 3. Minus 14 plus 2 is negative 12. Z is equal to 2 plus 0, that's 2. And so, again, I now have another equation in 2 unknowns, and of course, crucially, those unknowns are both y and z, as they are here. And so what I'm going to do now is I'm going to take this equation right here, and I'm going to take this equation right here, and I'm going to combine them again in order to cancel one of the variables. I think the easiest thing to do is to take this equation right here and multiply it by 3. Because I notice that if I multiply this equation by 3, I will have 3y, and here I have 3y. And so if I multiply this equation by 3, I'll have 3y and 3y, and they will cancel for me. So I multiply this equation here by 3, I will have 3y, just put it under here, 3y. 3 times negative 4 is negative 12. Z is equal to 3 times 7 is 21. All right? I have plus 3y and plus 3y. I can get rid of this here right now. I have 3y and 3y, so I'm going to subtract them. I'm going to subtract them, and my y's will cancel. 3y minus 3y gives me 0y. Negative 12z minus times a minus. Don't forget that. Be careful, that's a plus. Minus times minus is a plus. So minus 12z plus 12z is plus 0z is equal to 2 minus 21, which is negative 19. 2 minus 21. On the left-hand side, I have 0y plus 0z, so that's just 0 is equal to negative 19. So I am ending up with 0 equals negative 19, which is clearly not true. 0 is equal to negative 19 this is an incorrect statement. Therefore, this tells me that this original system of equations does not have any solutions. So 0 does not equal negative 19, and so therefore there are no solutions. There are no solutions. Put another way, there are no values of x, y, and z that will simultaneously satisfy all three of these equations. Those values of x, y, and z simply do not exist. We would say that this system of equations is inconsistent. The system of equations is inconsistent. So be on the lookout. Be on the lookout for that. You may, as a student, get to this point and feel that you've made a mistake. And in fact, you haven't. What you've actually been asked to do is to solve a system of equations that in fact has no solutions. It is possible that that can happen. So you need to be on the lookout for it. So there is an example, and I hope that's helpful. All right.